Hello again. Well, I've made a considerable amount of progress on the toolmaker's microscope, and I'm nearly in the last phases of making the last few parts. What we're looking at now is this little kind of button on the top here is a part of the it's the base against which the prism rests for the microscope, and I need to mill a slot in it. I've already turned a little recess that will receive the prism neatly and allow the prism to lie flat on that surface. And there's a little groove, and if I bring the camera around, for the shaky, let's try and adjust the exposure. So you'll see that there's a groove, a little recess, and the prism just sits within that recess. I very carefully turned that so that the prism just drops into that space and will be cemented in later. And so what I'm going to do now is mill a slot equal to the depth of that recess, just to give the prism as clear line of sight as possible up the eyepiece tube or the side arm of the microscope. So I'm going to set the camera down again around the other side, and I'm going to just find the edge. This doesn't need to be a very precision job. I need to mill a slot about 1/2 inch wide, straight in there. So I'm going to set that up now. I don't think I need to go to very great lengths to find the precise edge, as long as I'm reasonably along a diameter, as long as I mill reasonably along a diameter, I should be fine. In fact, what I can do is just roughly center this over the center hole. Oh, blasted! I've moved in the wrong direction. Too many handles. I'll just zero this micrometer dial on the Y feed. I'll slide this back. I'm sorry, the camera's sitting on the mill table, so you're going to get a kind of driver's view of the workpiece view of the job. So I'm just going to take a very light shaving cut, and the minute I touch on, I know that'll be right on the edge of the workpiece. I'll describe how I've managed to secure this workpiece in a minute, and I kind of hope it's going to hold. You know what I've realised? It probably won't hold. The reason it won't hold is because it's screwed on. So there's a central hole. Let's bring the camera around again. I'm kind of thinking out loud here. Just the exposure. There's a central screwed hole, tapped 6BA, and the little mandrel, the stub held in the chuck, is similarly tapped, and I've got a grub screw holding the two pieces together, which was fine. I turned this workpiece. I turned all these features while the workpiece was still attached, say, before I parted it off. The back face of this is not a functional face. It just needs to be clean, and so after parting it off, I turned it around, put the grub screw on, and screwed this down the other way around, so I could just clean up the back face. And I have left a little oily washer in between the two surfaces, in this case, just to be sure that I can separate them later. But if you look at the direction that the mill is going to turn, see that the flutes of that cutter is going to unwind. It's going to kind of have an unscrewing action on this thing, which is screwed on clockwise. So I'm going to have to cut from the other side, so as to. Oh, is that going to work? No, it won't. I'll have to cut from the inside. So what I'll do is find a diameter, then drop the mill table, come in, and then mill out. Otherwise it's going to unscrew the workpiece, and that will be a bit of a palaver. I could really put a I could really mount a pin in there just to stop it turning, but I'll give that some thought. Let me just see how it goes. I'm just gonna touch off and find the edge to begin with. Right, the mill's pretty noisy. This is not a good way to work. Okay, I'm going to have to do a classic center finding exercise and work properly, because I can see this all ending in a bit of a disaster. Just going to change get the old hammer. Right, I'm gonna take this milling cut out and replace it with a center finder. Okay, so this is a Clarkson Auto Lock cutter holder, and there's a kind of collet here. We've got this this shell with a 3 Morse taper shank, a little spigot in there. I don't know if that's visible. There's a little spigot inside there. Sorry, there's not much light in this shot. And some threads, and this body threads into there. So, and it's got a tapered nose, and similarly it has collets, and so that taper squeezes the collets. But the milling cutters are threaded, and these collets are threaded as well. There's a bore down there that's threaded. As the milling cutters thread into that, the milling cutter takes into that little pip down the middle of bottom of the shell. And so the two threads working against each other stop the milling cutter riding out of the collet holder. So it's a very, very secure way of holding milling cutters. Right, I'm going to mount this center finder in the collet holder, but because the center finder doesn't have threads, it allows the collet to bottom out in the holder and doesn't actually tighten. So I use this little spacer or thickish washer to take up the difference. Otherwise the work doesn't tighten. Okay, so I've got all that together. There we are, that's better lighting. So I'll just put that in there, snug it up, and then there's a great big wrench which is off camera. Okay, so I've got the old sticky pin in there. I'll just give us a center point with this sufficient degree of accuracy. Right, safety glasses. So this point that I've just been playing with is fitted into a ball and socket joint up in the little holder, and it's held sufficiently tightly that you can just move it with something. You know, I'm using the back of a brass pair of tweezers, and you just push it until it stops running out. You can feel the wobble disappear. So now we know that the body of that so we know that the tip of the little center finder is exactly coincident with the mill's axis. So now I can steer it by eye down the middle of that centrally bored hole. I'm going to find my eyeglass on that side. Need to go towards the mill. A bit more. Oops, back it a little bit. Okay. So what I would need to do now is tighten the y-axis travel. So we know that's 0. I'm just going to zero this micrometer in case something does move. At least I'll have a 0 position. A 0 there. Although my x-axis handle is over on the left-hand side of the mill table at the moment, the micrometer dial is over on the right-hand side, because I swapped handles in a hurry. This mill, which is an Elliott Omni mill, they very thoughtfully provided only one handle, or one feed handle for the x-axis, or for the mill table. And because of the space constraints in my workshop, I either have to use left or right. Generally I use right, but I had the table all the way over to right the other day. So I had to move the handle over this side, and I was in a hurry, so I didn't bother moving the micrometer screw, or the micrometer thimble. Okay, so we've got 2 zeros. Now I need to bring her out. Actually, I wonder if I do need to bring her out. I'll just crank that over. Release the drawbar. And put the cutter back in. Actually, I prefer the other safety glasses, but I've lost them. The other safety glasses, which are probably better quality but don't give us good coverage, have disappeared, so I'll prevail with these ones. Just make sure this is nice and okay, so we know that is a centre line, and we also know that this milling cutter is 3/8 of an inch. It's a 3/8 cutter. Across the flute is 5/16. The shank measured 3/8. Hmm. 390 thou. Okay, so we call that, okay, so 390 thou. Let's take a single cut. Let's bring that up. I need my, a must in every engineer's toolbox. Cigarette papers measure approximately 1 thou. So if you want to get down to a surface or kind of edge finders, they work very well. Just wet it a bit. Get that out of the way. Okay, so I don't really want to cut much of the surface away because it's a precision surface for the prism to rest on. I'm just going to touch that paper by raising the knee of the mill. Alright, so that's my surface. I'm just going to reset the height dial here. That's 0. Right, it doesn't actually touch the metal. So go back up. Just hog most of this metal away. That's not really I don't think this really counts as hogging, but considering the delicacy of the part, 5 thou is about as deep as I want to go per pass. Alright, I'm going to stop a thou over the height. I'm not bothering with the auto feed. Right. So that is going to be effectively about 0.4 of an inch, 400 thousandths. Which means I need to do a 50 thou cut either side of that slot I've just made to finish it down to half an inch, which is just a kind of clearance size. It's not critical. Oh, that's interesting. That says 370 thou. How's that? Okay, 370 it is. So we'll take that's 15, so 75, 370. So we're 130 off. So we need to do 65 thou either side of that center line. I'll take it to depth. Okay, that I would say is about 2/10 under full depth. And in fact, I'm just shaving that surface, so exactly at the right depth. Okay. If this seems unnecessarily laborious, it's because I don't want to move the workpiece on its little mounting here, because it's not very securely mounted at all. So I'm taking very light cuts, very gentle on the workpiece. Lovely. Okay. That's that job done. Okay. Just a few words about my setup. I did not want to remove that little stub mandrel from the chuck in case I needed to return it to the lathe and do something to it, which I might in fact do. I might just clean up that burr, or I might just do that by hand with an escapement file. So what I've done is I've clamped my 4-jaw independent chuck into this mill vise, and because I'm only taking very light cuts, you know, I knew it wouldn't, you know, the safety of the job wouldn't be that much of an issue. I would never do a setup like this if I were taking cuts of any appreciable depth. And this is only aluminium, so we'll just slide that. Oh, and it's resting on parallels. I've got a rotten setup here for my mill vise. It's a very good mill vise, but I haven't yet sorted out a proper way of clamping it down. So I just kind of lash up, clamps and clamping pieces to hold it down. I have clocked it square to the axis, parallel to the axis. So that's that done. Good. I'm pleased that that's out of the way. I was a bit worried about that. So I've remounted the chuck. I just want to sharpen this cutter. Well, I don't want to sharpen it because I've been cutting this aluminium. It's built up on the surface of the cutter. I've just got a little Arkansas stone. I'm just kind of cleaning all the metal that's galled on the surface of the cutter, kind of scraping that away. It's a very good quality tool steel cutter, but the aluminium, I expect it's the temperature generated at the cutting surface that causes a kind of micro melting, which kind of welds the aluminium onto the tool bit, and you know, from time to time requires chipping away. Right, now I'm just going to take a very light shave, not even a shave. I can't afford to change the diameter of this piece, so I'm going to get rid of those burrs. Got a very slight run out. Very slight run out. So what I'll do is I'll file it. You might be surprised to hear that, but I've got an incredibly fine file. It's not an escapement file, but it's a number 7 file, which is about as smooth as you can expect to go, and it won't take any metal off to speak of. Just break this wire edge. Both edges are safe. Okay, I think that's cleaned that up. There might be a burr on this face now. This face is not an active face. It's not a reference surface of any kind. It's just a finished machine surface. So that doesn't matter too much if I file across that, but I want to keep it nice and neat. Inside corners are clean. I've got a very slight bit of crud in there. I think that's fine. So there you can see the finished article. The design didn't call for the central hole, but I can quite anticipate a time when, if I need to dismantle the microscope, that little hole might be useful for threading a long screw into and pulling the whole assembly out. I will show you how it works. So this little button fits into this tube like that. Right. Eventually the two will be cemented together. The whole thing will be anodized black. And later I will saw with the coping saw, or a jeweler's saw, a slot down there, so that this tube has a slot of an equal width to the slot I just milled. I don't really want to mill this tube because this tube's diameter and circularity is quite important in my view, because it's what guides the prism. So the prism sits on that flat face there, kind of 45 degrees to us and 45 degrees off in that direction. It's what changes the optical path of this microscope. And so this would go in there. This tube goes into the body of the microscope, he says. And so its concentricity and parallelism and circularity, in my view, are quite important. And I think if I were to mill a slot out of this using the miller, it'll distort. The danger of distorting the tube is quite high. Plus, how would you hold it? You know, I could devise many ways to hold it, but by the time I've set that up, I might as well have just cut it with a saw and filed the edges smooth. As I say, it's only if you imagine a slot straight across there, it allows the light to come out of the side and go up this tube, because of course that will be down there. And so what we need to do is create that slot so that the optical path can intersect this side arm. So that's what all that was about, and I will cut that slot with the jeweler saw and file it to have nice neat edges. So those are those two components. Oh yes, and I thought I'd just give you a closer view of the little very delicate little chucking arbor I've used to finish the back face of that little button, and also to hold it in the mill. There's a single grub screw in that surface there, and that's an oily washer, just a piece of paper. If you've seen some of the earlier footage of this saga, you will have known that I managed to weld various parts of the job together inadvertently by galling them onto each other, or by just jamming them onto each other too tightly. I was unable to separate them later, so very careful with that now. I don't want the job to bind up halfway through being made, so that's why I use that oily washer.